Hello, in this video we're going to be talking about sections 5.7 to 5.8 in Chemistry 1151. So we're always talking about mole conversions right now, and we talked about molar mass, and we talked about Avogadro's number, but there's also relationships between different things. And so remember that a balanced chemical equation tells us basically the number of moles of reactants and the number of moles of products. So a balanced chemical equation like this means 1 mole or 1 molecule of N2 and 1 mole or 1 molecule of O2 is 2 moles or 2 molecules of NO. Now we can think about in terms of molecules if we're thinking about individual pieces, but we can also think about them in large groups in terms of moles. And so we don't usually write the coefficient of 1, but we're writing it here for emphasis that this is a 1 to 1 to 2 mole ratio. So we call this a mole ratio. So the mole ratio would be 1 to 1 to 2 as far as the moles here. And we'll flesh that out a little bit more here. So the mole ratios being, if I write out 1 mole of N2, how many moles of O2 would that be equivalent to? Well, it would be equivalent to 1 mole of O2, right? Because there's 1 N2 and there's 1 O2. Let me do the oxygen in a different color so we can see. We can also say for every mole of N2, there are 2 moles of NO produced. And so this relationship would be the 1 mole N2 from the coefficient of 1 that's there or not there, and then 2 moles of NO. Or we could say 1 mole of O2 is equal to 2 moles of NO. And you could do literally any combination of these. You could do any combination of these to get this mole ratio.